Hi, welcome. This is the Additional Mathematics Form 5 textbook question, Chapter 2, Differentiation Summative Exercise. Okay, so in this video, we're going to go through all the questions in this practice. So we're going to start off with question number 1, the idea of limit. Okay, now take note that if you, for limit, when you substitute inside, like for example, if you put -2 inside, you notice your denominator 8 minus 2 minus 2 square. So this is going to give us 0, and any number divided by 0 is going to be undefined. Yeah, in fact, there's no solution here. So what we have to do is we have to simplify further before we substitute. So I'm going to show you here, over here. I'm going to write over here. So keep writing the limit. I think we can factorize this. 8 plus 2x minus x squared. We can factorize into 4. This is 2. X, and x is supposed to be plus 4 minus 2 to get 8 plus 2x minus x squared, and your denominator we can take out 2, left with 4 minus x squared. Now 4 minus x squared is actually in the form of a squared minus b squared. So when you factorize further, okay, let me write this down first. It's going to give us a plus b, so it's 2 plus x, and a minus b, 2 minus x. Now we can cancel these two. Yeah, so you're left with 4 minus x. Okay, keep writing your limit first. 4 minus x with a 2 minus x. So if I put -2 inside, so you get 4 minus minus 2 and 2 minus minus 2. So it's going to give us 6 over 8 or 3 over 4. Okay, so that is part A. Now part B, you have a square root. Now again, you can't put 0 directly, because if you put 0, this will be undefined. So you get 0 over 0. In fact, because if I sub this inside 0, I'll get 1, and 1 minus 1 is 0. 0 over 0 is again undefined. So we have to simplify first. Now to simplify expression involving surd, so we need to multiply top and bottom with its conjugate. This is 1 plus x squared minus 1. So its conjugate is square root 1 plus x squared plus 1 over square root 1 plus x squared plus 1. So this will give us, when you expand, it will give us 1 plus x squared minus 1. In fact, I don't have to put a bracket. I think don't need to put a bracket. Just like this. Then you minus 1 over x square root 1 plus x squared plus 1. So the 1 minus 1 can cancel out. So I'm left with x plus x squared with the x square root 1 plus x squared plus 1. Okay, and again, you notice that you can actually simplify the x. If you want, you can factorize it, as in we take out x first. So this is 1 plus x. This is x square root 1 plus x squared plus 1. So once you cancel the x, right, now when you substitute the 0, it's not going to give us 0 over 0 anymore, right? So this is going to give us 1 plus 0, square root 1 plus 0, this is just 1, so is 1 over 2. Alright, moving on to part C. So notice that part C also involving square root, the square root x squared plus 7. So again, we need to multiply top and bottom. This is 4 here, so I need to multiply top and bottom with its conjugate. 4 minus square root x squared plus 7, its conjugate is 4 . Okay, so sorry, this is supposed to be k, so let's find k, right? Right, so yeah, so 4 plus square root x squared plus 7, 4 plus square root x squared plus 7. Okay, let me simplify this first, then we're going to sub in the limit. You're given the limit is 8, so let's just simplify first. This is x approaching k, 9 minus x squared. Keep writing your bracket here. This is x squared plus 7. Now your denominator is going to give us 16 minus x squared plus 7. Now when you expand, this is very long. 9 minus x squared, 4 plus square root x squared plus 7. Now this 16, when you minus 7, you're left with 9. This is 9 minus x squared, isn't it? So we can now cancel these two. Yeah, you're now left with 4 plus square root x squared plus 7. Now as I sub inside, we know that this limit is now 8, so we put k inside. 4 plus square root k squared plus 7 is now 8. Square root k squared plus 7 is now 8 minus 4, which is just 4. K squared plus 7 is 4 squared, which is 16. 16 minus 7 is now 9. Square root of 9 is plus minus 3. Yeah, rather long, eh? Okay, so yep, that is for question number 1. So I would say some of the questions are a bit imbalanced in a way. Some, like question number 1, you can see a B and C is quite long and difficult, but question number 2 is relatively easy. Your final value unknown a given the limit is -3. Now in this case, you don't have to simplify, you don't have to, like, because this is -1. If you sub -1, you can get an exact value, unless you get 0 over 0, infinity over infinity, where we have to do some simplification first. Yeah, in this case we don't have to, we can just sub inside a minus 5, and this will be -1, sub -1 inside, plus 4, you get -3. So your limit is -3. Yeah? So this will be 3, -3. A minus 5 is now -9. A is just -4. Okay, so this is fairly simple. Alright, so let's move on to question number 3. This one involving differentiation. So we have to differentiate one by one. Okay, the first one, right? There are many ways you can differentiate this. Now I hope I can go through with you some of the techniques that I usually teach my student. In the event that you have a bracket below, when you differentiate, you put a negative in front, copy k times n, copy fx, increase the power by 1, and differentiate inside. Now I'll use this rather than using quotient rule. Some people will go and use quotient rule. It's not wrong, but this is much easier. You can see that this number, the power here is 1, and this is a constant. Yeah, the number on top is a constant. If you have, let's say, x over 2x plus 1, then you have no choice but to use quotient rule. If the number on top is a constant, don't need to use quotient rule. Yeah, in fact, quotient rule is going to be a lot harder than this. Okay, so now I'm going to use this formula here. Now I think it's fine if we write dy dx first. We can just let this be y. So when you use dy dx directly, you put a negative in front. 1 times 1 is 1. Yeah, then you copy the bracket 2x plus 1. You increase the power by 1, 2, and you differentiate inside the bracket. In this case, you still get 2. Yeah, differentiate 2x here, you get 2. So answer is -2, 2x plus 1 squared. Okay, now notice part B, you cannot use composite function only. You can't use composite function. Okay, now by the way, I decided a formula for you. This is a formula involving composite function where the bracket is below. If your bracket is on top, when you differentiate, we take k times n, copy fx power n, and differentiate inside. So we use this in the event that the bracket is on top. But take note that this must be k, constant. This is not constant. This is u. This is v. So we have to use uv prime u prime v. Now I like uv prime u prime v rather than uv prime u vu prime, because when I arrange in this form, factorization is easier. Yeah, when you differentiate, it's already arranged in a form easier to factorize. Okay, let me show you. So dy dx, what's your u? 4x. Differentiate v. Now here we have to use a composite function formula here, right? This formula over here. So you bring the power 5 down, you copy the bracket 2x minus 1, reduce the power by 1, 4, differentiate inside bracket 2, then you plus, differentiate u is 4, copy v, 2x minus 1 power 5. Now here we have two common factors. I think if you find it's a bit hard to factorize directly, some people find this a bit hard to do one shot, maybe I will write down this first. 40x, I simplify first. 2x minus 1 power 4, 4, 2x minus 1 power 5. This is easier to see, clearer to see. Now you have two common factors. The first common factor you can take out is between 40 and 4, we can take out 4, right? So the second one is between the bracket power 4 and bracket power 5, we always take out the smaller power, with being power 4. So we take out 4 and 2x minus 1 power 4. Now 40, if I take out 4, left with 10, and in this case it's 10x. The second term, if I've taken out 4, I'm left with 1, but 2x minus 1 power 5, if I've taken out power 4, I'm left with power 1. I just have to simplify this bracket, 2x minus 1 power 4, and this is 12x minus 1. Okay, there you go, that's your answer. Alright, I think part C I have to do here, part D I have to do below here. I don't have enough space for all. So part C, again, it is similar to this formula, because you can see at the top is a constant. So we can use composite function. So we put a negative in front. 6 times 2 is 12. Copy the bracket, increase the power by 1. When I differentiate inside the bracket, differentiate negative x is negative 1. So this is 12 with 2 minus x power 3. Yeah, so there you go. That's your answer for part C. Okay, part D, I'm going to do it here, right? So again, this is involving UV. I can see that because there is a power half here. Okay, so this is your U, this is your V. dy dx will be copy U, differentiate V. Yeah, bring the power half down, copy the bracket, reduce the power 1, half minus 1 is negative half. Now when I differentiate x, I just get 1. I differentiate inside the bracket, just get 1. Then you differentiate U, which is 1, and then you copy V, x plus 3 power negative half. Now there are two ways to look at it. Now some students may want to factorize directly. Now but when you factorize directly, then you get to think this way. And let me write down extra step for you. I just write one extra step here. Yeah, make it easier to see. Okay, well, this is half. I made a mistake. This is just half, no negative, same here. So now what can we take out? Now between half and 1, you can take out half. You should take out half, right? Between power negative half and negative 1, negative half and positive half, we should take out the smaller one, which is power negative half. So the first term, you're left with x. Now take note, when you take out half, you're actually dividing by half. When you divide by half, this will give us 2. And x power half, when you divide by x power negative half, is actually half plus minus a plus. So it's x power 1. So in this case, you should get x plus 3 to the power 1. Okay, I think I need to put a bracket here, sorry. This will be x plus 3 to the power 1. Okay, alright, so let me erase this. I don't want it. I don't want this. Okay, so now I'm left with 1 over 2. Bring the square root down. This will be x plus 2x plus 6. We can, if you want, you can factorize further, but I'll just write this first. 3x plus 6 to square root x plus 3. If you want, you can take out 3x plus 2 over 2 square root x plus 3. Okay, just to take note, some people may find this method a little bit harder, especially with dealing with power negative half. So I'm going to have another way for you. So right from here, perhaps it is easier you keep this as x over 2, keep the half down, the 2 down, and power negative half simply means 1 over square root. Okay, power negative half is 1 over square root x plus 3, and the second term I have here is just square root x plus 3. Now to simplify fraction like this, right, we have to multiply top and bottom with 2 square root x plus 3 so that they have the same denominator. So what I'm going to do here is, this is over 1, right? I'm going to times 2 square root x plus 3. I'm going to times with 2 square root x plus 3. So this square root x plus 3 times square root x plus 3 is just going to give us x plus 3, right? But remember there's a 2 in front, so I'll put a 2 in front of the bracket. So this is 2 square root x plus 3, which is going to give us the same thing, x plus 2x plus 6, 2 square root x plus 3, and this will be 3x plus 6, 2 square root x plus 3. And if you were to factorize this, yeah, it gives us the same answer as the previous one. Yeah, I think most people would say that second method is easier. Yeah, because you don't have to factorize power negative, yeah, or power negative half, right? Okay, so that is number 3. I hope you can see this. I know it's a little bit messy though. Okay, so question number 4. All right, so this is what we call a differential equation. So you have to differentiate and differentiate twice, in fact, and then you substitute inside this equation. So I think it's not difficult. Y is 3x minus x squared. So the first time you differentiate, you get 3 minus 2x. The second time you differentiate, you get negative 2. Okay, so if you look at the expression here, so you get y d square y dx square plus x dy dx plus 12. So this is now, what's your y? 3x minus x squared. What is your dy dx? Your dy dx is, sorry, your d square y dx square is minus 2. So I'm going to put minus 2 inside here. And then your x, you copy, your dy dx is 3 minus 2x plus 12. So when you expand, you get negative 6x plus 2x squared plus 3x minus 2x squared plus 12. The minus 2 and the 2x squared minus 2x squared can cancel, right? Now you're left with 12 minus 3x. Okay? Alright, C. Now subsequently find, B. Subsequently find the value of x which satisfies this equation. Now look at this. This whole thing is the same as what I have above here, but it's just equal 0. So we just let 12 minus 3x be 0. 3x is now 12. X is just 4. Okay. Moving on to question number 5. Now, the gradient of a curve y equals to ax plus b over x squared at point -1, -7, 2 is 2. Find the values of a and b. So here we have to form two equations and solve them simultaneously. The first equation, obviously, we can sub in the coordinate, -1, -7/2. Your y is -7/2. Your x is -1. Okay, so this will be minus a plus b. -1 squared is still 1, b over 1 is still b, -7/2. Now it's up to you how you want to simplify this. Some students may prefer to multiply by 2, get rid of fraction, b minus 2b minus 2a equals to -7. Leave it out first. The second equation you have to differentiate. Yeah, remember gradient can be found by differentiating the function. When you differentiate ax, you get a. When you differentiate b over x squared, is negative b over, negative 2b over x power 3. Now, by the way, I just want to highlight to you guys, because some of you may not be familiar with this formula. When I differentiate constant, I get 0. When I differentiate linear form, kx, you get k. When I differentiate axn, you bring the power down, copy x, reduce the power by 1. Now for me, I like to use the fourth formula. I do not know whether you are aware of this, because some teachers don't teach this method. Yeah, in school, you put a negative in front, copy a times n, copy x. Instead of reducing the power, we increase the power by 1. So this is much easier actually. So what I did here was I put a negative in front, right? I take b times b times 2, so it's 2b here. See, there's a negative in front. I copy x here. Yeah, this x has power 2. You increase the power by 1, you get x power 3. Now, at this point where x equals to -1, your gradient dy dx is 2. So I'm going to sub 2 inside here. This is a minus 2b over -1 cubed, which is still negative. So a minus 2b, minus a plus now. It is now 2. Okay, so maybe I made one of them as a subject, or you can use elimination. I think you can use elimination, right? Take equation 2 minus equation 1. So a minus 2a is 3a, 2b minus 2b 0, 2 minus 7 is going to be 9. So a is now 3. You can use substitution if you are not comfortable with elimination, you can use substitution. So sub inside any equation, say equation number 2, 3 plus 2b is 2, 2b is -1, b is -half. Okay. Yep. So if you find this formula is helpful, you can just take note of this. All right. So let's move on to question number 6. Okay. Question number 6 involves rate of change. Okay. Now to solve problem involving rate of change, we always look at what is the rate given. You normally have two different rates. For example, so if I want to find, okay, here they really mention a volume of a sphere, dv dt is 20 pi. Okay, so increasing at this rate. So dv dt, find the radius of the sphere when the rate of change of the radius, dr dt is 0.2. So the question is, how do I link them up? So you can see they have v, you have t, you have r. So we can find dv dr, and dv dr, we can use this chain rule, and you just have to put dt over here. We got dv dt from here, and this is dr dt, we just have to invert it. But first you need to find out what is the relationship between v and r. We know a sphere has this formula, volume of sphere is given by 4/3 pi r cubed. So when you differentiate, you should get 4 pi r squared. The 3 I bring down, I cancel with the 3 here. I copy pi, I copy 4, copy pi, copy r, reduce the power by 1, I get 2, 4 r power 2. Okay, my dv dr we know is 4 pi r squared. My dv dt is 20 pi. My dt dr is 1 over, now remember to invert this 0.2 because this is dr dt, whereas what I have here is dt dr. So 20 pi divided by 0.2 is just 100 pi. There's a lot of pi here. You can cancel 100 and divide by 4 is 25. The pi and pi can just strike it off here. Okay. Now, so square root of 25, r is just 5, and in this case the unit is in cm. Okay, moving on to question number 7. So here again you have equation in the form of composite function 6x squared plus 1 power half. This, in this case, you're finding approximate change in y. So step 1, we differentiate dy dx. So I like to use a fast way, put a negative in front, 14 times half, which is 7. Copy the bracket, increase the power by 1, 3 over 2, and differentiate inside. Now when you differentiate 6x squared, you should get 18x, and 18 times 7 is 126, right? Okay, sorry, there's an x squared here. This is, I think I made a mistake. This is x cubed, I wrote wrongly. So this will be 126x squared, 6x cubed plus 1, 3 over 2. Okay, now you're finding the approximate change in y when x increases from 2 to 2.05. Okay, now I think I need to show you roughly the graph. Okay, maybe the graph looks like this. Okay, initially your x is 2. So if I draw a line here, so I use a red color pen. So this line is a tangent. Yeah, the gradient, we need to find the gradient of the curve when x is 2. So when x is 2, your dy dx will be negative 126, 2 square, 6 times 2 cube. 2 cube is 8, plus 1, power 3 over 2. This will be negative 504. 6 times 8 is 49. 48 plus 1, 49. Square root of 49 is 7. 7 power 3, 343. So you can simplify this. 72 over 49. Yes, quite ugly number. That means this gradient of tangent at this point is 72 over 49. Now, your x actually increases from 2 to 2.05. So let's say 2.05 is over here. So you can draw a triangle here, and we say that this is your delta x. Yeah, your delta x actually increasing by 0.05. Okay, so delta x means small change in x. So you can take the final value 2.05 minus the initial value 2, you get 0.05. So remember, if your delta x is small, yeah, when delta x is small, delta y over delta x is approximately the same as your gradient of tangent dy dx. Okay, so your delta y, in this case I need to find my delta y, approximate change in y, divided by delta x, which is 0.05, must equals to my dy dx, which is negative 72 over 49. Okay, so you just have to multiply over. This is quite an ugly number. Yeah, use your calculator, you will get negative 0.0735. Okay, you can leave in fraction if you want. Okay, so this is only part A. Part B, approximate value of y when x is 2.05. Now, approximate value is different from approximate change. This is approximate change in y, your delta y. But your y will have an initial value. Initially, your x is 2. What is your initial value y? This is your initial value y. So that means we can find initial value y by substituting 2 inside your original function here. So it's 14 over square root 6 times 2 power 3, which is 8, plus 1. So this is 49. 14 divided by 49 is just 2 over 7. Yeah, oh sorry, square root 49 is just 7. 2, so it's 14 over 7, 2, right? Just 2, right? So initially your y is 2. Okay? So when your x increases by 0.05, my y reduces by 0.0735 approximately. Yeah? So what is your approximate value? Well, your approximate value is your initial value. This is your initial value. And sometimes I just don't write that. Now you can just write yi or just y. Then you have to add with your delta y, approximate change in y. See, initially your y is 2. When your x increases by 0.05, your y actually drop by 0.0735. So the new value of y, or the approximate value of y, is this. Is your initial value plus your changes in y. Since your initial value is 2, your change is negative 0.0735, you should get 1.927. Yeah, that is your approximate change in y. Okay, moving on to question number 8, right? Okay, this involves percentage of change, right? Okay, y is given as 1 over square root x, so find approximate change in y. So number 1, let's differentiate dy dx. Okay, before that, maybe I write the formula in the form of power half. So when you differentiate, you put a negative in front. 1 times half is just half. Copy x, increase the power by 1. Right? So this will be my dy dx. Okay, initially x changes from 4 by 2%. So initially x is 4. So my dy dx will be negative 1 over 2. This is 4 power 3 over 2. So you square root 4, you get 2. 2 power 3 is 8. 8 times 2, 16. If you're not sure, you can just use your calculator. Okay, what is your delta x? Now, when you change by 2%, increase by 2% in this case, 2 over 100 times original initial value is 4. So this will give us 0.08. So your delta x is 0.08. You're finding delta y. Remember, delta y divided delta x is your dy dx when your delta x is small. So my delta x is 0.08. My dy dx is negative 1 over 16. When I times over, my delta y is negative 0.005. Okay, now your x is now 4. Always need to find the initial value y. The initial value of x is 4. What's the initial value y? You sub inside your original function here. Square root 4 is half. You can write 0.05. So to find approximate change, the percentage of change in y. Now I just use symbol. You can just use anything. You can write in words. Is your delta y divided by your initial value y times 100. This is your initial value. Initial value y happens when your x has an initial value of 4. So we take negative 0.005 divided by 0.5 times 100. Yeah, this will give us negative 1%. So what we're saying is based on this function, we know that when your x increased by 2%, your y actually dropped by 1%. Okay? Moving on to question number 9. Yeah, I hope this is not too difficult for you. Alright, so your y is given as 3x squared minus 4x plus 6. So there's a small change in x by p% when x is 2. So you want to find your corresponding change in y. So again, I think we can just differentiate first. Dy dx, 6x minus 4. Initially x is 2. My dy dx is 6 times 2 minus 4, which is 12 minus 4, 8. My delta x, right, is increased by p%. So it's p over 100 from initial value of 2. So you times 2. So this will be 0.02 p. Yeah? I'll leave it in terms of p. Now, to find your delta y, I must divide by delta x 0.02 p and equate it with my dy dx, which is 8. So my delta y is 0.16 p. Okay. Now we are finding corresponding percentage of change in y. A percentage of change in y is my delta y divided by initial value y times 100. But I need to find initial value. I know initially x is 2. My y will be 3 times 2 square minus 4 times 2 plus 6. This is 12 minus 8 plus 6. This will give us 10. So my percentage of change in y is delta y, which is 0.16 p, divided by initial value is 10. I multiply by 100. Cancel, cancel. 1.6 p percent. Okay, that is number 9. Yep, let's move on to number 10. Okay, all right, diagram on the right shows your dy dx and d square y dx square. Okay, all right, for function y equals fx, it's given that fx passes through these 2 points. You're given 2 coordinates here. All right, and this coordinate. All right, so without finding the equation of the function, so we are determining the coordinate maximum, minimum of the graph. So this one you have to look at the graph. See, the red curve represent your dy dx. The blue line represent your d square y dx square. Remember, dy dx, okay, maybe I write this one more time. This is your curve. When you differentiate, you get dy dx. When you let it be 0, you have a turning point. If you differentiate one more time, there are 3 cases. More than 0 is minimum, equal 0 is in point of inflection, and less than 0 is a maximum, right? So by looking at the coordinate, right, we know when x equals to -1, you can see when x equals -1, your dy dx is 0. So we know it's a turning point. But the blue line is your d square y dx square, yeah, and it's -6, which is less than 0. So we know -1 and 6. Now this 6 is nothing to do with the graph. It's not mapped on the graph. This is your 6 is your y here, right? So -1, 6 is a maximum point. Then at the same time, when you look at x equals to 1, at x equals to 1, your dy dx, the red line, is still 0. So we know it's another turning point. But your d square y dx square, in this case, you can see is positive 6, which is more than 0. So we know it has to be a minimum point. So 1, 2, again the coordinates given, 1, 2 is a minimum point. Okay, now they ask us to sketch a graph. Okay, now a cubic function, right, should usually, if a is more than 0, it should be going like this, right? If it's less than 0, is the other way around. Now here we know the first -1, 6 is a maximum, so it will be a maximum first, -1, 6, followed by minimum 1, 2. So I know it's going to be this curve, right? So let's just do a sketch. Goes up, down, up. Okay, so and both are positive. So the whole graph is above the x-axis, right? So this will be 1. You can just label the coordinate would do that. This is 2. This is also 1. So my graph look like this. Okay, so this is a graph of y equals to fx. Okay, moving on to question number 11. Diagram on the right shows part of the curve y equals 3x power 4 minus 4x plus 2. So you're supposed to find equation tangent at point A 2, 1. So we start off by differentiating this function. So this will be, when you differentiate 3x cubed, 3 times 3 is 9, copy x, reduce the power by 1, 2, differentiate -4x is -4. Now we have to sub in, initially x is 2, your dy dx is now 9, 2 square minus 4, 9 times 4, 36, 36 minus 4 is 32. Okay, now I must say this coordinate is a little bit, not to say a little bit, it is wrong. Because when you sub x equals to 2 in your y, right, you should get 3, 2 power 3, minus 4, 2, plus 2. So this will be 8 minus 8 plus 2, which is 18. 24 minus 8 is 16, 16 plus 2 is 18. But the question gives us this 2, 1. So that's why I'm telling you that this coordinate is actually wrong. So I feel that it should change the graph. Yeah, it's supposed to be a little bit higher, and the coordinate here is supposed to be 2, 18. So the answer I'm giving you is based on the correct coordinate, not the wrong coordinate. So you may find the answer at the back in the book is different because I'm using the correct coordinate, not the wrong coordinate. If you sub x equals 2, you cannot get 1 and you get 18. So let's do equation of tangent. So we use y minus y1. Gradient tangent is 32, right? X minus x1. So your y is 32x minus 64 plus 18. Yep. Your y is 32x minus 46. Okay, so that is part A. So for part B, they say coordinate another point on the curve such that the tangent is parallel to tangent at point A. Now assuming this, let's say this is just 18, so we know this is your tangent. There is another point on the curve with the same gradient. So the gradient dy dx is still 32. So we'll just take 9x squared minus 4. Take this gradient function that we have, let it be 32. So 9x squared is now 36. When you divide by 9, you get 4. Square root is plus minus 2. Now we already have the first point. The first point is, the coordinate is already 2 here. So if you take another point, the second point will be x equals -2. But we need to find your y value, so we're going to sub inside 3 minus 2 cubed minus 4 minus 2 plus 2. This is -8 plus 8 plus 2, -16 plus 2, -4, -14, sorry. So your coordinate should be -2, -14. Okay, so moving on to question number 12. This is really long. Okay, so now diagram shows a right angle triangle. This is a right angle triangle ADB, so with a hypotenuse of 6, side 3. The triangle is rotated about AD, so to form a cone. So find the height and the volume of the cone. right? Such that the volume generated is maximum. So number one, we know volume of your cone is given by 1/3 pi r square h. Okay, but the problem is you can't differentiate when you have multiple variable. So we need to reduce it to a single, like v in terms of r or v in terms of h. So, and we know radius is r, height is h. So we can form a second equation, r squared plus h squared 6/3 square. Now, since they're finding height, if you're finding height h, it's better to find v in terms of h. So to find v in terms of h, I must get rid of r. So 6 squared is 36, root 3 squared is 3, so your r squared is 108 minus h squared. So this is your second equation. To get rid of r, I make r as a subject. In this case, r squared as a subject. We sub 2 in 1. So my volume is 1/3 pi, 108 minus h squared times h. Now when I times inside, I should get 36. 108 divided by 3 is 36. There's a pi here. There's another h. So it's 36 pi h. 1/3 pi h squared times h is h cubed. Okay, so I got v in terms of h, but I haven't got the height yet, so I need to differentiate. Remember, maximum minimum happens when your dv dh is 0, so we're going to differentiate first. Differentiate 36 pi h, you get 36 pi, right? Differentiate 1/3 pi h cubed, bring the cube down, power 3 down, cancel it. You're left with pi h squared. dv dh, let it be 0. In this case, I just bring this over, cancel the pi. H is square root 36. We'll just take positive 6. So I answer part A already. Find the height when the volume of the cone is maximum. Okay, to find the maximum volume, we just take h and substitute inside your v, inside of v here. So v max is 36 pi times 6 minus 1/3 pi 6 cubed. 36 times 6 is 1216 pi. This is 72 pi 144 pi cm cubed. Okay, now you don't have to do second order differentiation because the question didn't ask to show that it has maximum or minimum, so we just leave it like this. All right. Okay, next question. Now this question is very interesting because you're given Mukris drove his canoe from point A to C. A is 30 meter from B, nearest point B, and then C is x meter from B. Then he cycle from C to D. Okay, so I think the question should mention find the minimum, find the distance from B to C such that the time taken is minimum. Yeah, because if they don't mention, it's a bit hard for student to think about what is the equation that you're finding. You're actually finding the distance x when the time taken is minimum or maximum, right? So nothing mentioned about the time, so that's a problem. A lot of people don't know how to formulate the equation. Now, first thing, if you see a right angle triangle, we know we have to form another, introduce another unknown. So I'm going to call this as for displacement. You can use other symbol. I don't like to use d because if you were to differentiate, it's a bit hard. D stands for distance, right? There's a d when you differentiate. There's dy dx, the d in front. So I'll call this as displacement. Your displacement s square is now x square plus 30 square. So your s square, or maybe I just square it straight away, is x square plus 900 power half. All right, so this is your displacement. Okay, so he's supposed to roll from here to here and then cycle from here to here. All right, so the time taken to travel from A to C, let's say, is t1. So we know velocity is distance divided by time. So for the first part, the velocity is 40 meters per second. So your distance is x squared plus 900 power half. Your time, let's call this t1. and the distance is 40. So T1, if you bring up, bring down, is x squared plus 900 power half over 40. Okay, then he cycled from C to D. When you cycle from C to D, you can see if the BC is 400, this will be 400 minus x. So your displacement is 400 minus x. Again, displacement divided by time. So let's call the time here is T2. The velocity is 50. So T2 is 400 minus x over 50. Now, your total time, I'm going to call it T, capital T, is T1 plus T2. Okay, and to find dt dx, we bring the power half down. The half times 40 is 80, copy x squared, reduce the power by 1, differentiate inside. Now, the 400 divided by 50, actually this is, can you think of it as 80 minus 1 over 50x. So when you differentiate 80, you get 0. When you differentiate negative 1 over 50x, you will just get negative 1 over 50. Right? Maybe you want to split first before you differentiate, it will be easier. So my dt dx is, okay, I'm going to cancel 2 and 80 here. So you get x, this will be 40. And I think we can just leave it as square root, x squared plus 900 minus 1 over 50. Okay, now at the turning point, maximum minimum, dt dx is 0. So yeah, I'm going to bring the 1 over 50 over, right? And we can cross multiply. So I'm going to bring the square root over here, so I get x squared plus 900. The 5 I bring over, so it's going to give us 504 with the x. So when I square both sides, I get x squared plus 900. This will be 25 over 16 x squared. Now 25 over 16, when you minus x, is just 9 over 16 minus 1 x squared. So this one you bring over 900. So this is 1600. Square root it, your x is just 40 meter. So we know that to take a minimum time, the distance x should be 40 meter. Okay, quite challenging, yeah? Alright, let's move on to question number 14. Alright, the size of a cuboid expands at this rate. So if you have a cuboid, let's say the length of side is x, your dx dt is now 2. You're finding the rate of change of the total surface area when the volume is 8. Now, total surface area, we know that one face is x squared. So a cuboid will have 6 faces, yeah, top, bottom, left, right, front and back, so it's 6x squared. So when you differentiate dA dx, you should get 12x. Now the thing is, what should I sub inside for x? We know we are finding the rate of change of your surface area. That means you're finding dA dt when the volume is 8. So volume, V equals to 8. So for cuboid, volume is x cubed, x times x times x is 8. Cube root of 8 is 2. So we know we have to sub in x with 2. This will give us 24. Now, I'm finding dA dt. dA dt is dA dx times dx dt. Now, I already know my dx dt. My dx dt is 2. My dA dx is 24. So 24 times 2, 48. If you want to write the unit, it should be cm square per second. Okay. Alright, moving on to number 15 here. Diagram on the right shows part of the curve. Y equals 6x minus x squared. So here is the point x 0. Now show that area triangle is given by half bracket 6x minus x cubed. So now area of triangle, we know we can use half times base times height. Your base is just x, your height is just y. You can see your height here is y, your base is just x. So now my answer is given in terms of x, there's no y. So I need the second information. My second information, in fact, is already given, 6x minus x squared. Yeah, the equation of this curve over here. So we sub equation 2 in 1. So my area is half x, 6 minus x squared. Now notice that the question only multiplied the x inside, so I get 6x squared minus x power 3. That's all right, I got this answer already. B, given that x increases at this rate, yeah, that means dx dt is 2. Find the rate of increase of a when x is 2. So we know we have to differentiate. So maybe I differentiate first, dA dx. Now remember, I thought you know, my student is when you have half, leave the half outside, just differentiate inside. 12x minus 3x squared, right? You don't have to multiply inside, but if you want, you can. If you want, you can times inside. This will be 6x minus 3 over 2x squared. Now I think since the question, if you want to cut short your working, right, we can just count one shot. Okay, the first part, find the rate of increase of a. We know our dx dt is 2. Yeah, dx dt is already given, is 2. You're finding dA dt, right? So dA dt is dA with the dt here. I have to put dx here so I can sub inside. Correct? I need to use the dx over here. Now my dA dx, when x equals to 2, I should use 6 times 2, 3 over 2, 2 squared. You multiply with 2. Okay, 6 times 2 is 12. 12 minus 6, this is 6 times 2 also. Answer is 12. But for Roman 2, you want x equals to 5. So your dA dt is 6 times 5, 3 over 2, 5 square. I just times 2. I just change, sub in different value of x inside my dA dx. So this will give us 30 minus 75 over 2. So it's negative 7.5 times 2, negative 15. Okay, so this is your, since the question asks for rate of decrease, so you don't go and put negative lah. Rate of decrease, sorry, rate of decrease is just 15. Yeah, 15 what? C. This is unit, unit per. What is the unit? They never mentioned. Per second. Yeah. So this one will be 12 unit per second. All right. Number 16. I think this is the last one. Yeah. All right. So diagram shows inverted cone with the base radius height is given. Now volume. Show that the volume of water in the cone is given by this. Now, okay, you're given V in terms of H. So to show this, right, we know number 1, right, volume of a cone is 103 pi r square H. The problem is I have 2 unknown here, whereas I only have 1 unknown here, right? So this is where you have to use similarity, similar triangle, right? So we can use the ratio here. You see, R divided by 12, the ratio will be the same as H divided by 20. So I'm going to write R over 12 H over 20. So, and your final answer is in terms of H, so I must get rid of R. 12 divided by 20 is 3 over 5. So R is now 3 over 5H. As I sub 2 in 1, my volume is 1 over 3 pi, 3 over 5H square H. Now 3 over 5, if you square it, is 9 over 25 H square times H. So this is 3 over 25 pi H cube. Yeah, I got V in terms of H. Okay, next one. Water leaks out through a small hole at the tip of the cone. So find the small change in the volume, yeah, when the height decreases from 5 to 4.99. So what's your delta H? Delta H is 4.99 minus 5, negative 0.01. So, but you need to find your dV dH first. I know when you differentiate this function here, bring the power down, you get 9 over 25 pi H squared. and always sub in the initial value. What's your initial value? 5. So your dv dh is 9 over 25 pi 5 squared. So this is going to give us 9 pi. Now remember, delta y over delta x is dy dx. Now this is true when delta x is small, right? But I'm not using delta y now, I'm using delta v because this is volume, delta h because it's the height, dv dh, right? So your delta v divided by delta h, which is negative 0.01, must equals 9 pi. My delta v is negative 0.09 pi. If you want to write the unit, is cm cubed. Okay, this is B Roman 1. B Roman 2, show that when a decrease of p% in the height of water will cause a decrease of 3% in the volume. Now, here's the problem. We do not know what is the initial value of h. So I'm just going to leave it in terms of h, okay? So we know that when a h decrease negative, decrease by p%, so it's negative p over 100 times h, because I don't know what's the h, yeah? So h is a initial value if you like. So now, your delta v will be the same, divided by delta h, which is negative p over 100 h, must be the same as your dv dh. Now my dv dh is 9 over 25 pi h squared. So when you multiply over delta v, okay, let's take 9 over 25 times p over 100 h. Yeah? So this will give us negative 9 over 2500 pi h cubed p. Now whether you put a p in front, p at the back, doesn't matter. That's your delta p. But to find the percentage of change in your volume, I must take my delta v here, h squared p, divided by my initial value. My initial value of v is this. This is your initial value. Yeah? 3 over 25 pi h cubed. Now the good news is you can cancel your h cubed and h cubed, pi and pi, and even this 25. So 9 divided by 20, this 25 can cancel with 100, right? 9 divided by 3 is just 3. So this is negative, sorry, I should use a black pen, negative 3 over 100p, so it's negative 3p%. So yeah, you're supposed to show that it will cause a decrease of 3%. So yeah, decrease means negative, so it's negative 3%. Well, that's all. That's the end of this video, right? Thank you for watching. Yeah, I hope you learned a lot from the discussion.